In this video, we're going to cover the ideas underlying logistic regression. We use logistic regression when we're interested in an outcome variable that's yes or no, right? So something like getting a job, graduating high school, developing a pressure sore. These are yes or no kinds of questions. And what we want to know is, do any of our predictor variables make those outcomes more likely or less likely to happen? When we talk about a yes or no outcome, we're talking about a dichotomous outcome variable. Dichotomous just means it has two possible values, yes or no, true or false, 1 or 0. So here on the left, you're seeing general linear regression. We've got a predictor variable as our x variable, and the outcome variable is the y variable. And what we're interested in is if there's a relationship between the value of the x variable and the value of the outcome or y variable. This is what logistic regression looks like. So we only have two possible values for our outcome, either yes or no, true or false, 1 or 0. So we can't have a straight line. And what we're interested in is whether the value of this predictor variable makes a value of 1 or true or yes more or less likely. Now, since we can't get a line here, that means we can't make a linear equation. So what they do instead is they take the log of this, and that turns it into a straight line. So when we talk about logistic regression and you hear about log odds, the equation that we're getting is calculating the log odds. So how do you interpret this? So this is what a logistic regression equation looks like, and it looks exactly the same as a linear regression equation. The difference is this y is not the value of y. This is the odds of y being true. And if your x variable, your predictor variable, is continuous, so it's something like height or weight, income, then an increase in 1 unit of your predictor variable increases the odds of y being true by your beta. If x sub I itself is dichotomous, so graduated high school, gender, anything with two possible values, xi, this being true or 1, increases the odds of y being true by beta. The p-value we get is actually the same between linear and logistic regression. The p-value is talking about what is the probability that this beta is actually 0, that this has no effect on, in this case, the log odds of this being true.